Welcome to the second part for the Shape Node Poly assignment video. In this video, we will go over writing the polygon.cpp file as well as the ellipse.cpp file and the shape node poly _ test file. In part one, we defined all of the header classes, so the class for shape in shape.h, the polygon class in polygon.h, and ellipse class in ellipse.h. So let's dive into polygon.cpp. The first thing you're going to want to do is you are going to want to write an include statement for the header file for Polygon, as well as CMath for the C library that we're going to use in this file, as well as the IO stream. So you can pause the video now and make sure you have all these include statements. And the next thing we'll do is we'll start implementing the class that we defined in polygon.h. So you'll notice the first thing that we'll need to do is we'll need to implement the constructor for polygons, as well as the getArea method. So let's do that right now. So let's first start with the Polygon Constructor. So this will build unique kinds of polygon objects, and we do this by stating the class name. So polygon : polygon with an open parentheses, and we need to pass in all of the parameters that a polygon will take. So it will take in 4 sides that are all doubles. So S1, S2 should be a 2, S3, and S4. So we can just copy these and then throw them in to our constructor. Great. And then the next thing we're going to want to do is we need to assign basically the parameters that we have here that are named the same things. So they're S1, S2, S3, S4. These are all the attributes that polygons have. We need to assign them to, we need to assign those parameters, so S1, S2, S3, S4, to the ones that we're passing in. So we could call this something like side 1, side 2, side 3, and side 4. And what we'd be doing is saying S1 equals side 1, S2 equals side 2, S3 equals side 3, S4 equals side 4. Yet, in the remaining methods in this class, which are the getArea method, when we want to refer to a side, we will use S1, S2, S3, S4. Okay, and the next thing we will want to do is we will make the getArea method. So it returns a double, and it is in the polygon class. So we'll say polygon : getArea. And now we need to define how to calculate the area for a polygon. And here we are going to rely on using the code from geometric area to basically, we're going to use the code from the geometric area assignment to calculate the kinds of shapes. So you'll need to open the geometric area program and go to the getArea function that takes in 4 sides and copy and paste the code from the getArea function in geometric area that takes in 4 sides. So when you copy and paste that in, it should look something like this. So you declare a length, a width, and an area, and then you're basically making comparisons about the sides to see if it's a if it's a rectangle and which sides are going to be the length versus the width, and then you just multiply the length and width together, and then you return that area. So that all of this code is the code that was provided to you in your geometric area assignment, and if you just go to the getArea function that calculates a four-sided polygon, you will find this here. Okay, the next thing we'll need to do is we're going to build the triangle class. Okay, and we do that by saying triangle, and then we're going to do the constructor for the triangle. And triangles, as we look here, they take in three sides. And if you remember in part one, we built the triangle class to inherit from Polygon. So it will use the public methods in the class of Polygon. Namely, we can use the Polygon Constructor and its getArea in triangle. So I'll show you what I mean by that. So we put in the parameters for the triangle constructor, which are three sides, and then when we don't need these brackets yet. What we're going to do is we're going to pass in. So every single time we want to use the triangle constructor, we are just going to pass it into the Polygon constructor. And we can do that by writing colon, then we're going to say polygon, and then we're going to pass in to the Polygon constructor the triangle's sides. So S1, S2, S3, and then since triangles don't have another side, we're going to pass in 0.0, so a double value for 0 as the fourth side. And then we can open and close the class and just leave it like that. So you can leave your brackets just like this once you're done passing it into the Polygon constructor. So that's how we're going to build our triangle constructor. The next method we need to build is a getArea method for triangles. So how do we calculate the area of a triangle given three sides? And this, so calculating the area of a triangle based on three sides, this was provided for you also in the geometric area assignment under the getArea that takes in three sides. And it uses something called Heron's formula, if you're interested. And so I'm going to copy and paste the area solution from my geometric area code, which looks something like this. We declare a side variable that adds up all three of our sides provided, and then divides by 2, and then we use Heron's formula on that. So this is provided in your geometric area assignment. So you'll want to go into geometric area, find the getArea function that takes in three sides, and then copy and paste the formula for calculating the area. And okay, so this wraps up the Polygon class. So basically we have a Polygon constructor that takes in four sides. We have a getArea method that we implement for it, and then the triangle class inherits from the Polygon class, and we can use the Polygon constructor in the way we construct our triangles. We basically just pass in to Polygon, and then it builds us a collection of data that's just based out of three sides, not four. So three sides of the values, and then a 0 side. So when we call methods with triangles, it just takes, basically we'll have a unique object that's based on from the constructor in Polygon, and we can call getArea methods on that object. And so when we call the getArea on a specific triangle, it will just do these calculations with the three sides that the triangle consists of. So the next class we need to work on is the ellipse class. So in video 1, this is what we did, we made a ellipse class that's based on shape. Ellipses, they have a minor and major radii. And we declared the constructor for the ellipse, the getArea method, and then we made a circle that's based on ellipses that only has one radius. And so we're going to basically do the same thing that we did with triangles and polygons, where we made the constructor for a triangle based on a polygon. We're going to do the same thing in the ellipse file, where we base the constructor for a circle on an ellipse. So let's see what I mean by that by jumping into the ellipse file, ellipse.cpp. And we first need to include the header file for ellipses. And then we need to include the IO stream. And then we need using namespace standard. Okay, so the first thing we'll want to do is build the ellipse constructor for its objects. And then we do that is we'll say ellipse : ellipse, and then it takes in one radius R1 and another radius R2. And then what we'll do is I'm going to actually change this to be RAID1 and RAID2, and we'll assign R1 to whatever value that we pass in as rad1, then R2 as rad2. Great. And then we need to do the getArea method for ellipses. And we'll say its return type is a double, and we'll say ellipse : getArea. So basically, the formula for calculating an ellipse is pretty simple. So we're going to declare an area variable that's a double, and we'll return that area. And now let's calculate the area. So what does the area of an ellipse equal? Well, it equals pi. And so a circle is pi r squared, where there's just one radius in a circle. And an ellipse is pi r1 times r2. So you'll have a minor and a major radii. And that just means one radius is smaller than the other, so it gives it kind of an oval shape. So if it's elongated on the x-axis, that will be the major radii, and if it's smaller on the y-axis, that will be the minor radii. We don't need to know which axis is the minor and major radii, but just in case you're confused with the terminology. So pi times r1 times r2, and then return the area. Okay, so you're probably wondering, okay, now do we need to do the circle class? And we do not need to build the constructor with the circle class in this file, because we actually did it in here. We basically said the circle constructor is inherits from the ellipse constructor, and we pass in to the ellipse constructor r and r. So the single r that we provide for a circle when we are building a circle object. So we say, I want to make a circle that has a radius 2. What will happen is in your circle class that's based on ellipse, it will pass into the ellipse constructor the same radius for the ellipse. So when you calculate an area of a circle, it will also pass in r and r to ellipse's getArea, which is pi r squared. What do you think about it? So since a circle is essentially just an ellipse with two of the same identical radii, when we pass it r and r into the getArea function, it will return pi r squared, which is what we want for a circle's area. Whereas in the case of the Polygon class, we needed to define a different area, a different way of calculating the area for a triangle than polygons. So we had to write a new get area method. Moreover, triangles have 3 sides, so we had to pass in a 0 for the 4th argument in Polygon. So let's see. The final thing we'll be doing in part 2 of this video series is writing the shape poly test .cpp function. So I've been mentioning the geometric area code a lot since this assignment's kind of like an introduction to object inheritance using a similar assignment to geometric area. So what we're going to do is we're going to base the main file for shape node polytest on your geometric area code. So this is the geometric area code, and for example, when I was getting the area calculations for a triangle, it is from this get area method, which is defined down here. So that's essentially where I took it from, and this should look familiar for the polygon. So what we're going to do is, the first thing we're going to do is we're going to copy the main function from geometric area, and we're going to put it into shape node poly test. So shape node poly test.cpp, we throw in that main function, and this will prompt the user to basically enter certain sides for a shape, and then we will make a few modifications in our shape node poly test so that we're building objects that are certain shapes. But first thing, we need to declare all of the header files that we're going to be using in this main function, which is basically all the header files. So you're going to include polygon.h, include shape.h, include ellipse.h, and then we haven't gotten to the point class yet, but you'll also want to include point.h. Finally, you'll include your input-output stream, and you'll write new using namespace standard. Great. And let's run through this main function again from geometric area. So basically what we do is we declare a number of sides variable, and we basically create this response loop where a person can continue again and again to calculate shapes based on their choosing. And they first enter the number of sides, and then based on how many sides the user puts in, we will know what kind of shape they want to calculate. Okay, so if the shape is, if the number of sides is 0, we're going to assume that that is a circle with a certain radius. Okay, so let's go into this case first where we're doing a circle, and let's build a circle object. So the way we are going to build any one of these objects is first we're going to declare it as a shape, because if you remember from part 1, we built this generic abstract class called shape, which basically has a get area method. So any kind of shape will be able to have this get area method, but we leave it to other classes which inherit from shape to implement this get area method. So for example, polygons, they inherit from the shape method, and then we implement a unique get area method for polygons. Same thing with triangles, same things with ellipses, and same thing with circles. So let's build a circle, but the class we're going to specify is shape. So we're going to say shape, and we're going to make a pointer, so the asterisk sign, and then we'll just call this shape S, so pointer to an object. And the kind of object we're going to build is a circle, and we need to also, since we're using this pointer, we need to allocate new memory after runtime. So if that's confusing, basically we need to include this new keyword in here so that we don't get a compiler issue basically in C++. So we're going to say new circle, and what do we pass in for the circle's radius? Well, we're going to pass in this first variable. It's what we assigned as input, as console input. So the user types in, my radius is 20, and then we have that 20 stored in first. So we pass in first for the radius. Okay, and then now we need to calculate the area of this object called S. So what we're going to do here is we need to change these getArea methods. They don't take in parameters anymore. If we call the getArea method for a certain kind of object, this being a circle, it will know to use the circle's getArea method. And the way we do that is we need to say S and then do an arrow. So we're going to hit dash followed by a less than sign to make this arrow, S to getArea, and then end line. So this will calculate the area of a circle and then output it to the console. Also, I noticed that in the geometric area tests, it also considers a circle to be one-sided. So what we're going to do is we are going to delete this else if statement right here. And also, in the case that the user enters 1 as the number of sides, we will still calculate a circle. And now we need to do a shape with 2 sides. So a shape with 2 sides, this will be our ellipse. So by 2 sides, we're going to enter a major and a minor radius. So we're going to output enter the radius, enter the major radius, and then we're going to say we're going to store whatever the user inputs to the first float. So these just stand for sides. First side, second side, third side, fourth side. So just like that. And then we need to receive the second radius. So enter the minor radius. And then we assign that to second. And then we need to build the shape object. So shape pointer S equals new ellipse. And then we pass in first as the R1 and second as the R2. And now we can literally just copy this output statement to output the area for this object. So area is this getArea. Okay, moving on. So we only have actually 2 more situations. One where we have 3 sides. So this would be the triangle class. And where we have 4 sides, and that would be the polygon class. So what we're going to do is after we get all 3 sides, we will build the triangle object, which is based off the shape class again. So by saying shape pointer S equals new triangle, and then we're going to pass in all 3 sides, first, second, and third. And then we will output what the area of that triangle is in the same way that we outputted all of the other areas. And we can delete the calls to getArea from the geometric area assignment, because now we are doing them using objects instead, which are not taking in parameters. Instead, they are based on the class that these objects are written in, whether it be triangle or the ellipse or the circle. So now moving on to a 4-sided object, that would be our polygon class. So we are going to build a shape pointer S. That's based off, that's a new polygon, and we're going to pass in first, second, third, and fourth as all of its side arguments. So first, second, third, and fourth. And then we are going to output what the area of this polygon object is in the same way we did it in the previous 3 output statements. Cout area is, S to get area, and line. And if we have any number of sides that are larger than 4, we will say the area cannot be calculated, and we'll ask the person, do they want to calculate something again? In which case we will go back to the top of this while loop and do it all over again. So we're going to save this. This is the user-facing file, so the main function that is actually speaking to our user and getting information about what kind of shape they want to calculate. So that is all for part 2. We did the main file for shape node poly_test. We did we are actually not doing the shape.cpp class. That is not, we do not need to build a constructor for shapes since it's an abstract class. All we're doing is we use this virtual method. That just means that this doesn't really exist as a method. It rather exists as a blueprint for all the kinds of classes that will inherit and be based on shape. So basically, what do all shapes have in common? Okay, they have a getArea method. What's a shape? Well, for example, the Polygon class, that's a shape. It's based on the public shape class. We made a getArea function for it. What else is a shape? Well, a triangle, due to this inheritance hierarchy, is a shape because a triangle inherits from polygons. Triangles are polygons. Polygons are shapes. Thus, transitive and going down the hierarchy, triangles are shapes. Cool. Similarly, our ellipse class, ellipse.h. Ellipses they inherit from shapes. And circles, they inherit from ellipses. So both ellipses and circles are shapes. And they both implement the getArea method that is specified in the abstract class using this virtual method. So hopefully that just kind of wrapped everything together a little bit more neatly. So, you know, this sort of object inheritance idea and polymorphism is a little bit more conceptually clear. So again, this is your first time working with objects in classes, and this assignment too is also a little bit on the trickier side, but as you do more stuff with objects and classes, it should be a little bit easier. I know there's just a lot of syntax stuff you're seeing for the first time, and that's why I'm here to help. So stay tuned for part 3, and best of luck.